Hello students, my name is Sukumar Giri, faculty in the Department of Statistics of Barakpur Rashtraguru Surendranath College. Today I will discuss the topic on analysis of variance, that is ANOVA, which is helpful for mainly Sem-III statistics general student as well as statistics honors students, but I will mainly focus on the theory of analysis of variance for Sem-III general statistics students. First, before going to one way ANOVA, I will discuss what do you mean by ANOVA. What is ANOVA? ANOVA, analysis of variance, is a technique of splitting total variance, that is total variation, into different component sum of square. What is ANOVA? Analysis of variance that is ANOVA is the technique of splitting the total variance that is variations into different component sum of square, into different component sum of squares. ANOVA, analysis of variance, is a general technique. ANOVA is a general technique developed by R.A. Fisher, developed by R.A. Fisher. Suppose, for instance, there are three different machines in a factory. Suppose three different machines in a factory for producing small iron balls for producing small iron balls from same raw material, and machines are operated by three different persons on rotation. On rotation. Samples of iron balls produced by three different machines, produced by three different machines are collected and their weights are measured, and their weights are measured. The weights of iron balls, the weights of all iron balls will in general not to be same. In general not to be same, because of assignable source of variation and unassignable source of variation. Because of assignable sources of variation and unassignable source of variation. Here assignable sources of variations are those due to variation of different machines and variations of different operators. Here assignable sources of variation are those due to variations for different machines and due to variations for different operators. Different operators. Unassignable source of variations is called random error, which is unexplained due to different machine, between machines and between the operators. With the help of analysis of variance, one can perform certain tests of hypothesis, and provide estimates for different components of variation. Next, assumption in analysis of variance. Assumptions in analysis of variance. First assumption, linear model. Linear model. An observed value is the sum of an observed value is the sum of assignable, fixed, and or random effects and unassignable random error and unassignable random error. Second one is independence and homoscedasticity of errors. Independence and homoscedasticity of errors. The errors are independently distributed. The errors are independently distributed with same variance. With same variance. The third one is normality of errors. Normality of errors and also of random effects in the model. The errors are normally distributed normally distributed and random effects if any in the model also be normally distributed, distributed. Now I start one-way ANOVA, analysis of one-way ANOVA, that is one-way classified data. How to analyze one-way classified data? One-way classified data, that is one-way ANOVA. Let A be an factor with p levels, or a factor A classified into P classes. Let A be a factor with P levels or a factor A is classified into P classes. P classes. Then the linear model is then the linear model is Yij equal to mu I plus Eij, where I equal to 1 to P and j equal to 1 to Ni. That is A be a factor, A be a factor classified into P classes A1, A2, AI dot 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 AP. Observations in the A1 classes are Y11, Y12 dot 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 Y1j dot 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 Y1N1. The observation corresponding to A2 class Y21, Y22, Y2j dot 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 Y2N2. Similarly, the observation corresponding to AI class are Yi1, Yi2 dot 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 Yij dot 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 Yini. Similarly, the observations corresponding to Pth class are Yp1, Yp2, Ypj dot 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 Ypnp. Then Yij equal to jth observation corresponding to ith class. Here I equal to 1, 2, dot 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 p. Mu I equal to mean effect due to ith class. Mean effect due to ith class. Eij equal to random error in Yij, random error in Yij. Now, mu I equal to mu plus alpha I, where mu equal to general effect, alpha I equal to effect due to ith class. Now, linear model is the final linear model is Yij equal to mu plus alpha I plus Eij. Then assumptions are, first one is summation over I n I alpha I equal to 0. Second assumption is Eij random error follows independently and identically distributed, IID follows normal 0 sigma E square, mean 0 variance sigma E square. Next hypothesis is the null hypothesis such that mu 1 equal to mu 2 equal to dot equal to mu p. Equivalently, we have to test null hypothesis such that alpha 1 equal to alpha 2 equal to dot alpha p equal to 0. Alternative hypothesis against alternative H1 such that at least 1 alpha I not equal to 0, I equal to 1 to p. Next analysis unrestricted residual sum of square R1 square equal to minimizing double sum Eij square, summation over I, summation over j equal to minimizing summation over I, summation over j Yij minus mu minus alpha I whole square. Here we have to estimate the values of mu and alpha I. So, we use least square method to estimate the values of mu and alpha I. The least square estimates are mu cap equal to y 0 0, where y 0 0 equal to 1 by n summation double sum over I over j y I j, where summation n I summation over I equal to 1 to p equal to n. Alpha I cap equal to y I 0 minus y 0 0, where y I 0 equal to 1 by n I summation over j y I j. Next, we put the values of mu and alpha I in this equation. Therefore, R1 square equal to double sum y I j minus mu cap minus alpha I cap square, double sum y I j minus y 0 0 minus y I 0 plus y 0 0 whole square equal to double sum y I j minus y I 0 square. This is called sum of square due to error. Under null hypothesis, linear model is y I j equal to mu plus E I j. R2 square equal to minimizing double sum E I j square minus equal to double sum y I j minus mu cap square equal to double sum y I j minus y 0 0 square. Therefore, R 0 square equal to R 2 square minus R 1 square. R 2 square equal to double sum y I j minus y 0 0 whole square, that is called total sum of squares. Therefore, R 0 square equal to R 2 square minus R 1 square equal to this minus this. Here all product terms are 0. summation double summation over I summation over j y I 0 minus y 0 0 square equal to summation over I n I y I 0 minus y 0 0 square, that is called SSA, sum of square due to factor A. Total sum of square y I j minus y 0 0 square equal to double sum y I j minus y I j minus y I 0 plus y I 0 minus y 0 0 whole square equal to summation y I j minus y I 0 square plus double sum y I 0 minus y 0 0 square. Here the product terms is 0 because sum of deviation about mean always 0. Summation over I over j y I j minus y I 0 square summation over I n I y I 0 minus y 0 0 square this implies that total sum of square equal to sum of square due to error plus sum of square due to factor A. Now, ANOVA table is ANOVA table is first column source of variation, source of variation. Next, degrees of freedom. Next, sum of squares. Next, mean square. Source of variation short form SV. Due to factor A, error, then total, then total. Due to factor A, degrees of freedom p minus 1, total observations is n, degrees of freedom n minus 1, error rate degrees of freedom n minus p, SS sum of square due to factor A, sum of square due to error, total sum of square. MSA equal to SSA by corresponding degrees of freedom P minus 1, MSE equal to SSE by corresponding degrees of freedom n minus p. Next column F0, F calculated, MSA by MSE. Last column tabulated F value, F tab, F alpha, where alpha is level of significance, alpha comma p minus 1 comma n minus p. Now, the conclusion is we reject null hypothesis H naught at alpha level of significance, at alpha level of significance if F0 equal to MSA by MSE greater than F alpha comma p minus 1 comma n minus p, otherwise accept null hypothesis H naught. Example of one way classified data is marks of a number of madhyamik examinees from different schools, collected for studying for studying inter-school variation when classified to schools from which the students came represent one way classified ডেটা। আজ এই পর্যন্তই। নেক্সট ক্লাসে টু ওয়ে ক্লাসিফাইড ডেটা আমরা সলভ করব।